Hey everyone, and welcome back to the channel. Today, we're diving deep into a fundamental concept that every software engineer, cloud architect, and IT student absolutely must grasp: the shared responsibility model in cloud security. The cloud promises incredible agility and scalability, but it also introduces a critical question: when something goes wrong, who's actually responsible for securing it? Is it Amazon, Google, Microsoft, or is it you, the customer? Misunderstanding this model is a leading cause of cloud security breaches. So, get ready, because we're going to break down this crucial concept, illustrate it with practical examples, and show you exactly how to navigate your responsibilities effectively, using real-world code snippets from our accompanying lab. Let's get started. Alright, let's kick things off by defining the two main pillars of the shared responsibility model: security of the cloud and security in the cloud. Think of it like this: when you move into an apartment, your landlord is responsible for the building's foundational security, the structural integrity, the common area fire alarms, the locks on the main entrance. This is the cloud provider's job: security of the cloud. Providers like AWS, Azure, and GCP are in charge of protecting the global infrastructure that runs all the services they offer. This includes their physical data centers, the hardware within those centers, the network infrastructure, and the hypervisors that abstract the underlying compute, storage, and database services. They handle things like physical security, environmental controls, network security of their core infrastructure, and ensuring the availability of their services. You don't worry about someone breaking into an AWS data center; that's on AWS. Now, if the landlord is responsible for the building, you, as the tenant, are responsible for what happens inside your apartment. This is where security in the cloud comes in. This is your domain, your responsibility. What you put in the cloud, and how you configure it, falls squarely on your shoulders. This includes managing your data, its encryption, integrity, and access controls. It extends to your identity and access management, or IAM, defining who can access your resources and what actions they can perform. You're also responsible for your network and firewall configurations, like security groups and network ACLs. If you're running virtual machines, patching the operating system and securing your applications are also your tasks. The specific extent of your responsibility will vary depending on the service model you choose, whether it's infrastructure as a service, IaaS, platform as a service, PaaS, or software as a service, SaaS, but fundamentally, if you deploy it, you secure it. Let's get practical and talk about perhaps the most critical customer responsibility: identity and access management, coupled with data security. Who has access to your sensitive data, and what can they do with it? This is where least privilege comes into play. Our accompanying lab includes an IAM policy, customer_least_privilege_s3_access.json, which demonstrates best practice. This policy grants a user or role only the necessary permissions to read and write objects in a specific S3 bucket. Notice how it explicitly lists actions like S3, getObject, and S3, putObject, and limits the resource to a particular S3 bucket ARN. This granular control is vital. It also ensures data at rest is encrypted, which is a key part of your data security responsibility. The more specific your permissions, the smaller your attack surface. However, it's incredibly easy to get IAM wrong, and the consequences can be catastrophic. One of the most common and dangerous misconfigurations is creating overly permissive IAM policies or publicly exposing data. Our lab intentionally includes misconfigured_overly_permissive_s3_access.json to highlight this risk. Look closely at this policy: principal, combined with action, S3, getObject, on a resource that points to an entire bucket. This literally means anyone on the internet can read objects from that bucket. Another statement in this same file grants S3 on resource, meaning all S3 actions on all S3 resources. This is a severe violation of the principle of least privilege and a direct path to data breaches. These kinds of misconfigurations are unfortunately common, leading to sensitive information being accidentally exposed. Beyond IAM and data, your network and firewall configurations are another huge part of your security in the cloud responsibilities. Imagine you launch an EC2 instance. Who controls what traffic can reach that instance or leave it? You do. Through security groups and network ACLs. Our customer_IAM_EC2_management.json policy shows how you'd grant permissions to a user or role to manage EC2 instances, and crucially, their associated security groups. This includes actions like EC2, authorize security group ingress, and EC2, revoke security group ingress. When configuring these, you must be precise. Opening SSH, port 22, or RDP, port 3389, to 0.0.0.0/0, which means the entire internet, is a classic misstep highlighted in our misconfiguration_risks.md. You should always restrict access to known IP ranges or specific internal security groups to minimize your exposure. Moving on, let's talk about the operating systems and applications you deploy. If you're running virtual machines in the cloud, like an EC2 instance, patching that operating system, configuring its firewalls, and securing the applications running on it are entirely your responsibility. The cloud provider doesn't log into your EC2 instances to run Windows updates or apt-get upgrade. That's on you. Similarly, if you deploy your own custom application, securing that application code, managing its dependencies, and ensuring it's free from vulnerabilities are all critical customer tasks. Even with managed services, while the platform itself is secured by the provider, the data and configuration you put into it, and any application logic you write, remain your responsibility. Neglecting these aspects is like leaving your apartment door wide open while your landlord ensures the main building door is locked tight. It defeats the purpose. Now, how do skilled cloud professionals manage these responsibilities effectively? Often, through infrastructure as code, or IAC. Our lab includes Terraform configurations in terraform/main.tf to illustrate this. Here, we define an S3 bucket with an ACL equals private and, crucially, enable server-side encryption and block all public access at the bucket level. This is a proactive measure against those dangerous misconfigurations we discussed earlier. We also attach our S3_least_privilege_ policy to an IAM user, ensuring our data access is tightly controlled. IAC allows you to define your cloud infrastructure and security policies in a declarative, version-controlled way. This not only automates deployments but also helps enforce security best practices consistently, making it far less likely to introduce human error and misconfigurations. Even with IAC and well-defined policies, vigilance is key. How do you know if a misconfiguration has slipped through, or if an old resource is now insecure? This is where auditing and monitoring come into play. Our lab features a Python audit script, script/audit_s3_public_access.py, designed to check your S3 buckets for public access configurations. This script systematically examines bucket ACLs, bucket policies, and block public access settings for each bucket in your account. It's a practical example of how you, as the customer, can actively monitor and enforce your security in the cloud responsibilities. Regular audits, coupled with robust logging and centralized monitoring solutions like CloudTrail and CloudWatch, are indispensable for detecting and responding to potential security incidents swiftly. Don't just set it and forget it, continuously verify your security posture. So, to recap, the shared responsibility model is not about blame, but about clear ownership. The cloud provider secures the underlying infrastructure, security of the cloud. You, the customer, are responsible for everything you deploy and configure on that infrastructure, security in the cloud. From encrypting your data and crafting precise IAM policies to hardening your operating systems, securing your applications, and defining your network rules, your actions directly dictate your cloud security posture. Embrace least privilege, leverage infrastructure as code, and implement continuous auditing. Understanding this model empowers you to build truly secure and resilient cloud environments. If you found this deep dive into the shared responsibility model helpful, please give this video a thumbs up, share it with your colleagues, and subscribe for more in-depth technical content. Check out the accompanying code lab in the description to get hands-on with these concepts yourself. Thanks for watching, and I'll see you in the next one.